Hi group, we're going to look today just at single displacement reactions. This lesson uh, is the continuation from part one where we examine combustion, synthesis, and decomposition reactions. Single displacement is as it sounds, it's a taking away or a kicking out or displacing of one element in the presence of another. And it involves a specific type of reaction where an element and a compound are brought together. The general form is shown here. So A is our element, BC is our compound. B could be the element from the compound that is displaced or removed. And then what is often the case is a new compound forms. A and B are metal elements, and generally C would be a non-metal ion or possibly a polyatomic ion. Show a video clip here just to introduce a very common example of how to remove silver from a solution containing silver ions.
When a piece of copper metal is placed in a solution containing silver ions, solid silver crystallizes on the copper. While the silver crystals grow, copper ions are also released into solution, giving the solution a blue color.
Okay, and in the lab what we're going to be doing is investigating what's called the activity series. The activity series generally refers to elements, and because the single displacement reactions involves active metal elements or active elements, we are going to try to determine which elements are more reactive relative to others. So a simple conclusion that we're going to come to is that a given metal element A will displace a metal ion from a compound B. Notice that we could also be referring to a halogen, and the activity series that we're going to examine is for metal elements, but there is a similar activity series for halogens, and you'll see it in your textbook. It looks like this. So the halogens are on the right, and the activity series for the metal elements, including hydrogen as well, is on the left. So continuing here, if the element A is positioned higher in the series than B, then A will displace it, B will be kicked out, and A will form an ionic compound. So in that case, the higher on the activity series, the more reactive, the more likely they are to engage in bonding. And so the more reactive element is going to form the compound, the least reactive gets kicked out on its own as an element. The elemental form may be atomic, it may be diatomic. We have to keep in mind the form of an element whenever we're writing the reaction equation. Now the activity series is what's called an empirical table. So empirical referring to observational or gathered by experiment. And so it's used to predict, and it's useful if we're considering whether or not an element and a compound, when mixed, will undergo a chemical reaction. It's one thing to write the reaction equation, but it may not occur. So we will use this activity series to predict if a single displacement reaction will in fact occur based on that relative order of reactivity. Electronegativity tables are similar in that the higher the electronegativity of nonmetals, they tend to be more reactive. The lower the electronegativity of metals, they tend to be more reactive. This is found in your textbook on page 127. Electronegativity values themselves are somewhat empirical, but probably were arrived at through a calculation. And so we would consider that more of a theoretical prediction if we use electronegativity tables. This is the table that we're going to set up in the lab. This investigation we're just going to do as a whole class, investigation 3.3.2, developing an activity series. We're going to be combining metal elements in their elemental form, chunks of metal on the left, with ionic solutions containing those same elements at the top. And the combination of a metal element and a compound containing perhaps the same element or different elements will be examined. And the reaction will either occur or will not occur, and we'll tabulate the results. From that, we'll be able to determine which elements here were most reactive, and we'll be able to order them relatively and come up with some kind of an activity series horizontally, or if we decide we want it to match the empirical activity series in the textbook. In that case, we would just simply order them vertically um, for preference only. The higher they are in the vertical series, the more reactive they are. It's a little bit easier to remember than if we order them left to right. Once that's done, you'll be carrying out with a partner a designed activity that you and your partner will do, which is investigation 3.3.2, which is testing the activity series, and that will involve hydrochloric acid in dilute form and a selection of elements. And in that case, because hydrogen is similar to metals in that it loses electrons to form positive ions, it is included in the activity series. We find it here towards the bottom. It is not very reactive as an element, but we find that in a compound form it can be easily displaced. And we'll be testing this empirical activity series to see how much that's supported in reality. Okay, I'll just close at this point with one more application, which is that because of single displacement, bonded elements in a compound form can be extracted from ores, and this is a common application or a common use of this type of reaction whereby a precious metal or an element that is needed is removed from a compound found in the ground, in rock, by reacting it with a more active or more reactive element. So the example there shown would be to displace copper for use in household wiring and other applications as an element from copper sulfate using an active metal iron. Okay, extraction of metals is a useful application of single displacement. However, quite often this is done in the high school chemistry lab using acid and maybe less precious metals such as zinc or magnesium. So I have a couple of clips here to show this, and you will verify these same two reactions in your testing the activity series lab. Let's have a look.
When we place the element zinc in hydrochloric acid, it reacts, forming zinc chloride. The reaction also produces bubbles of gaseous hydrogen. When we put magnesium metal into aqueous hydrochloric acid, the two react. Aqueous magnesium chloride is formed along with gaseous hydrogen.
Just coming back to this activity series and a little bit of summary of the assigned work that we're going to be looking at in this section 3.3. We'll be reading this section. I would always encourage you to read the section, particularly when the lesson just summarizes the ideas and it's very brief. I'm just condensing what I've done often is have read the section and looked for key ideas. So that's a good practice for you to do. And then the follow-up questions, take note there for the 3Us, number 5 only for the 3Us, and probably not if we haven't covered chapter 1. The remainder of the questions for both groups we'll look at over the next couple days. We will be doing some in-class lab work with the developing activity series, investigation, and ultimately you'll be designing an experiment for the testing the activity series, which you'll find in your textbook on pages 131 to 132. That will be a full report write-up. I'll give a summary of the different parts of a lab report and what needs to go into each of them, and you should be getting some feedback from your investigation, which we did the other day, that involved the combustion reaction of butane, and the gases were captured, and we looked at cobalt chloride paper and the lime water as tests for carbon dioxide and water. So the little write-up that you have done should have been submitted at this point, and that was in your lab notebook. The questions were in your textbook, and those were found, I'll look it up in the textbook, it was found on page 116 and 117. The analysis and evaluation were to have been included. taking the comments and feedback from that will help you with your full report write-up. So I'll see you in class tomorrow, and we'll look at starting this developing the activity series investigation, and you'll have some class time to work out your procedure for the testing activity series. Take care.